Hey guys, it's Miss Barrett, your fave math teacher ever, and I am here to introduce to you a whole new world of graphs. Get it? See the joke there? We're going to do cosecant and secant in these notes, and we will save tangent and cotangent for Monday. So we're going to start by talking about just in general what these graphs look like. Remember guys, sine and cosecant are reciprocals of each other. So when we start graphing, we want to think in terms of reciprocals. We know already all about the graph of sine of x. We know that the x values are 0, pi over 2, pi, 3 pi over 2, and 2 pi. And the y values for sine are going to be 0, 1, 0, -1, and 0. So when we think about the reciprocal function, cosecant of x, okay, my x values stay the same. We always start with the same x values, but my y values are going to be the reciprocals of the y values of sine. So we have to think about this, guys. What is the reciprocal of 0? Think of 0 as 0 over 1. The reciprocal of that is going to be 1 over 0, okay? So that's undefined, which I'm going to use a u to write undefined. So the reciprocal of 0 is undefined. The reciprocal of 1 over 1, is still 1. The reciprocal of 0 is undefined again. Sorry, the pen is hard to write on this app, FYI. The reciprocal of -1 is still -1. And the reciprocal of 0, again, is undefined. So this right here is your new and improved y values for the cosecant function. So how do we actually graph this? Whoa, let's not do that. There we go. So how do we actually, okay, this is weird. Give me a second, guys. There we go. So how do we actually graph this? Well, we're going to start by graphing our sine function to give us kind of an idea of what my graph is going to look like. So we're going to start by graphing sine. Let's graph our x values, 0, pi over 2, pi, this would be 3 pi over 2, and this would be 2 pi. And let's make this here 1 and -1. And let's go ahead and graph our sine function. 0, 0, we go up, we go back to 0, we go down, we go back up to 0. So this is going to be my sine function, and I would ask that you guys dash your sine function, which is really hard to do on this app, which I'm not a fan of right now, but you guys kind of get the idea. We want to make this dashed because this is not at all part of the graph. It's just going to give us a guide to actually make the graph. So now here we have our graphs. The next thing we want to do, you guys, is plot the asymptotes. So wherever I have an undefined value, I'm actually going to have a vertical asymptote. So I'm going to graph those right now. So these are going to happen at the corresponding x values. So the first, the third, and the last. That's going to be 0, pi, and 2 pi. That's where my asymptotes are going to happen. So I'm going to draw these in. Again, these are dotted lines. 0, pi, 2 pi. It's wherever the sine function's actually at 0. And that's it. Now I'm just going to draw parabolas. It looks like parabolas. And the vertex of each parabola is going to hit the sine function like this, and that's it. And I just graphed my first cosecant graph. And now we're going to do the same thing with secant, except secant is the reciprocal of cosine. So we're actually going to graph cosine first, and then we're going to put in the asymptotes and make the parabolas, and we are going to graph our secant graph. After that, we're just going to do 2 examples and call it a day. So let's go. So if you can remember, the y values for the cosine function start with 1. So it goes 1.
Are you wearing like a microphone?
No. 0, -1, 0, back to 1. Okay, so again, the zeros become undefined. Reciprocal of 1 is 1. Reciprocal of 0, undefined. Reciprocal of -1 is -1. Reciprocal of 0, undefined. Reciprocal of 1 is 1. Okay, so we're going to go ahead and graph our cosine function as kind of a helper, and then we will go ahead and graph the secant function. So if you guys can remember, we got 0, we got pi over 2. I apologize for my handwriting. This app is terrible for writing. I gotta put in a complaint.
Excuses.
That would be my fiance. And then 2 pi. Okay. So this is cosine, so we're going from 1 to -1. And we got 1, 0, -1, 0, back to 1. Make sure you guys make this dotted. Gorgeous. Okay, so the asymptotes go where the zeros are. So this is right here at pi over 2 and at 3 pi over 2. And now we can draw in our parabolas of secant here. And then technically there's one here. You can make it the full parabola. And one there. Guys, that's it. Soak it in. Let's do 2 examples and we'll be done.
Soak it in, guys.
So here we are on the next page. Guys, I'm just going to show you how to graph this. We will talk all about phase shift, amplitude, period, all that good stuff on Monday when we talk about tangent and cotangent graphs. So let's go ahead and start with the original values. Secant's reciprocal function is cosine. So we're going to go off of cosine. My chart here is going to all be graphing cosine function, not secant function. To graph secant, we're literally just going to graph the cosine version of this, and then we are going to draw in our asymptotes and just draw in the parabolas based on the cosine version of this graph. Oh man, this app is terrible, guys. Bear with me. So we have our original points. We have 1. We have 0. We have -1. We have 0. And we have 1. So let's see. We are going to multiply all of our y values by -2. And we are going to multiply all of our x values by 2 as well, because we take the reciprocal of 1 over 2, which is 2. So this is kind of nice. We get 0 here. Pi over 2 times 2, the 2's cancel. We just get pi. This one's going to be 2 pi. The 2's will cancel here. We go 3 pi, so clearly this is increasing by pi. Here we get 4 pi. Okay, next we get -2, 0, +2, 0, -2. And let's go ahead and graph that cosine version of the graph. So we got 0, We got pi. We got 2 pi. We got 3 pi. And 4 pi. And this time the graph goes down to -2. Excuse me. And goes up to 2. So now we are going to go ahead and graph the cosine function. So we have 0, -2. Pi is at 0. Then we go up to 2, back to 0, back down to -2. And we are going to make a dotted, because this is not the actual graph. So the dashed. Now wherever there's zeros, that's where the asymptotes go. And now you guys, that's it. We're just going to draw in our parabolas. I like to draw in all of the ones that we can. So it'll look like this. You will only have to do very basic versions of this. All right, so that's that. And let's do one more. Okay, so the reciprocal of cosecant is sine. So what we want to graph is 3 sine of x minus pi over 4, wow, minus 1. Boy, all right, so we got 0, we got 1, we got 0, -1 and 0. Let's do the y's first. So we got 3y and -1. So 0 minus 1 is -1. The new center line is moving down to -1, and that's important here. This one gives me 3 times 1 is 3 minus 1 would be 2. Back to -1. -1 times 3 is -3 minus 1 is -4. And then again back to -1. So now for my x values, we're shifting all of them right pi over 4. So it's going to be x plus pi over 4. Okay, so 0 plus pi over 4 is going to be pi over 4. Pi over 2 plus pi over 4 is going to give me 3 pi over 4. Okay, pi plus pi over 4 would be 5 pi over 4. Three over 2 plus 3 pi over 2 plus pi over 4 is going to be 7 pi over 4. And then we get 9 pi over 4. Okay, so let's start graphing this. We go 0. Pi over 4, 3 pi over 4, 5 pi over 4, 7, and 9. This is disgraceful. I'm sorry about my handwriting, guys. I won't. This app is no good. All right, we got 1, we got 2, and it looks like we're going to go down to -4. So -1, -2, -3, -4. Whew, okay, so let's see, we got pi over 4. Now, guys, keep in mind, the new center line is down at -1 because it's been shifted, the whole graph's been shifted down 1. So wherever the graph of sine hits the center line, that's where the vertical asymptotes are going to be. So that's kind of key here. We got pi over 4 down at -1. That's where one of the vertical asymptotes will be. Okay, next we have 3 pi over 4 is going up to 2. Then back down to -1. Next we're going down to -4 and back up to -1. So just to draw this out with the dashes, looks like this. Okay, so the vertical asymptotes go where the corresponding sine function hits the center lines. And at the minimums and maximums, we draw the parabolas. And there you have it. That's really it. So we will talk about amplitude, period, vertical shift, phase shift. It's all the same as when we've done sine and cosine functions. I wouldn't worry too much about it. In terms of actually being assessed on this, it'll be very basic or multiple choice or extra credit. So this is something that, it's important to understand where these graphs are coming from and what the relationships are, and that's about it. Cosine and tangent, and cotangent are going to be much more important to really understand and to be able to graph by hand. So we're going to do that together in class on Monday. So I hope you guys are having a great weekend, and I'll see you soon. Go Cubs. Peace.